For more problems and videos like this for linear algebra, you can take a look at Sarai Studies, link is in the description box below. We're told to solve the system of equations, so the first thing I do is label the coefficients that I don't have, then I highlight my coefficients and also my ending values. Then I rewrite it as a matrix. It's literally just rewriting all the numbers you see here in here, but just don't include the variables or the operations. Now to solve a system, we first have to get it into row echelon form. As always, we start with the column that is not all zeros, so that's this one over here. Our pivot position is the one at the top. We want to make sure the entry inside the pivot position is not 0. It's not, so we're good. And then we just want to clear out everything below it. So if it's not 0, we kill it. So this is not 0, so we have to kill this. So I want to kill something that is in row 2. This is in row 2. I want to use whatever's in my pivot position to do so. My pivot position is in row 1. Then I'm going to do plus, and then whatever's here, that's row 2. So these always should match. And then to find out what I need to change in my equation here to get this to be a 0, I'm going to write these rows right here. So row 1 is this, row 2 is this. I treat it as an equation, plus sign, just like I said over here. Then I ask myself, what's my goal? My goal is for this first entry to be 0. So here the first entry should be 0. Then I focus on this column and I ask myself, what can I do so that this plus this is going to give me 0? I just always change whatever's in my pivot position to help me get this to be a 0. So I use my pivot position to kill this. So in here, I'm only looking at this 1 and I'm asking myself, how can I change this? So when I add that plus this is going to give me 0. Well, I can have this be a minus 2. So I would have to multiply this by a minus 2, but if I do something to one entry, I have to do it to all of them in the same row, which is why we do minus 2 times row 1. That way this becomes a negative 2, this becomes a negative 4, and then 2 times 3, that's 6, but it's negative. And then you can just add as always. Now we have 2 minus 2, that's 0, just like we wanted it to be. This is 0, and this is 0. And then this matches up with this. This is my new row 2. So since the only thing that I changed is row 2, that means that row 1 is going to stay the same, and then row 2 is going to be my new row 2. We're going to replace this with this. Instead of repeating the steps again and then getting to the point where you know you can stop, you can just check if it's in row echelon form by using ZO. So remember, are all 0 rows at the bottom of the matrix? Yes, this is a 0 row, it's at the bottom. Check. Does it pass the staircase hack? Well, first you have to identify your leading entries. Leading entries are the first entries that you see that are not 0 in each row, so this is your leading entry, and then here we have no leading entries because all of them are 0. So remember the staircase hack, we start with our leading entry, and then we go, and we only go down when we see another leading entry, but there aren't any other leading entries, and so this passes the staircase hack because it doesn't matter what the width is, it just matters the height, so the height of each step is 1, so we're good there. And are all entries under the leading entries 0? Well, this is a leading entry. Are all of the entries under it 0? Yes, so this is in row echelon form. If we translate this back into an equation, we just write 0, 0, 0, and then attach the variables. So that would be x1 plus x2 and then equal to 0. And that's just 0 is equal to 0. And when we see that, that's many solutions. That means that these two lines intersect at many points. So now that you know, you're going to go ahead and keep going to find out what the solutions are by putting it into reduced row echelon form. Now, if you remember ZO plus 1c, this is row echelon form, this is reduced. All you need to do is make sure that all of the leading entries are 1 and that they're the only numbers that are not 0 in their columns. This is the only leading entry I have. It's 1. Check. Is it the only number that's not 0 in its column? Well, this is its column. This is the only number other than 0, so we're good. So it's already in reduced row echelon form as well. We can rewrite it back into a system that's easier to solve. Again, the strategy is always just write your numbers 1, 2, 3, leave some spaces, 0, 0, 0. This just means equal signs. And then remember that each column contains the coefficients that are going to be attached to the first variable, and then this one's going to be attached to the second variable. So there's going to be x1, x1, and then plus, x2, x2. Recall that these systems are equivalent, they just look different. Now, if we remove all the zeros, we're just left with this. This is the solution to our system, but it's not very clear what the solution actually is. There is another form that we can describe the solution, and that's called parametric form. And what you need to know about that is recall what a pivot column is. A pivot column is a column that contains your pivot position. So in this case, we know that this was a pivot position. So this is a pivot column. But here there was never a pivot because we were already in row echelon form. So we never went on to find another pivot. So therefore, because this doesn't contain a pivot, then it's not a pivot column. And so the rule is, if you have a column that's not a pivot column, the variable that is attached to the coefficients in these columns, in this case that's x2, is going to be something called a free variable. And so the idea of parametric vector form is that you want to write all of the other variables that are attached to pivot columns in terms of that free variable. So a free variable is a variable that's free to be anything you want it to be. So it's equal to x2. In this case, it could be anything. We can have it be 6, we can have it be 5. It doesn't matter. It's free to be anything. So if you know that you can make this anything, then you might as well write x1 in terms of this. So that's just a fancy way of saying, hey, put this to the other side. So this becomes x1 is equal to 3 minus 2x2. Now the idea of parametric vector form is that we can have x2 be anything. So let's say it's 1. So then if I plug in 1 here, then now I redefined x1 as 3 minus, well this is 2, which is 1. But then I can have x2 be anything, so it could be 4, and then for each time I plug it in, I'll get a different x1, which is why there's many solutions to this system. The system intersects at many points. So this here is what we call parametric form. Remember, you're just looking for the columns that don't contain your pivot positions, and the variables attached to those columns, in this case it's x2, is going to be your free variable. And that's it for this video. I'll see you in the next.